According to the National Electrical Code, specifically Table 430.22b, motors used intermittently, such as those in elevators, can be calculated at 85%. This is different from motors that run continuously, which typically require a 125% calculation to account for continuous load. When dealing with an elevator motor, the first step is to identify the motor's nameplate amperage. This is the full load amperage the motor is designed to draw under normal operating conditions. For example, if the nameplate amperage is 121 amps, you would then apply the 85% factor due to its intermittent use. To calculate the adjusted amperage, you would multiply 121 amps by 0.85, which results in approximately 103 amps. This adjusted amperage is what you will use to determine the appropriate wire size and overcurrent protection. Next is selecting the correct wire size. Based on the calculated amperage of 103 amps, you need to choose a conductor that is rated to carry at least that much current. According to the National Electrical Code, the ampacity of conductors must be considered based on their insulation type and installation conditions. In this case, using #3 copper THHN wire, which typically has an ampacity of 110 amps, is an acceptable size. The THHN insulation is a common choice for electrical wiring and has a temperature rating suitable for many installations. However, it's crucial to consult the appropriate ampacity tables in the NEC, specifically Table 310.16, to ensure that the chosen conductor size is adequate for the specific installation conditions, including ambient temperature and the number of conductors in a raceway. These factors can affect the conductor's ability to dissipate heat and thus reduce its ampacity. Overcurrent protection is essential to protect the motor and wiring from overloads and short circuits. In this example, a 110 amp breaker is selected as the overcurrent protection device. The breaker should be sized no larger than the ampacity of the conductor. It is important to note that the NEC has specific rules for motor overcurrent protection, which can be found in Article 430. These rules may allow for slightly higher overcurrent protection ratings in certain circumstances, but it is generally recommended to stay as close as possible to the conductor ampacity. A shunt trip breaker adds an additional layer of safety by allowing the elevator control system to remotely trip the breaker in case of an emergency or malfunction. This is typically installed in the elevator room for easy access and control. The shunt trip mechanism can be activated by various safety devices, such as emergency stop buttons or fire alarm systems, to quickly disconnect power to the elevator motor. When installing the wiring, it's important to follow all applicable codes and regulations. The NEC provides detailed requirements for wiring methods, grounding, and bonding. Ensure that all connections are made properly and that the wiring is adequately supported and protected from physical damage. Grounding is a critical aspect of electrical safety. The grounding system provides a low impedance path for fault currents to return to the source, which helps to trap the overcurrent protection device and prevent electrical shock hazards. The grounding conductor should be sized according to the NEC, based on the size of the unrounded conductors. Bonding is also important to ensure that all metal parts of the electrical system are at the same potential. This helps to minimize the risk of electrical shock and prevent the buildup of static electricity. The bonding conductors should be properly connected to all metal enclosures, raceways, and equipment. Additionally, it is important to consider voltage drop in the circuit. Voltage drop occurs when the voltage at the load is less than the voltage at the source due to the impedance of the conductors. Excessive voltage drop can cause equipment to malfunction or overheat. The NEC recommends limiting voltage drop to no more than 5% for power circuits. To calculate voltage drop, you need to know the length of the circuit, the current flowing through the circuit, and the impedance of the conductors. There are several online voltage drop calculators that can help you with this calculation. If the voltage drop is excessive, you may need to increase the size of the conductors or shorten the length of the circuit. Another important consideration is the disconnecting means. The NEC requires a disconnecting means to be installed within sight of the motor control equipment. This allows qualified personnel to safely disconnect power to the motor for maintenance or repair. The disconnecting means must be readily accessible and clearly labeled. Before energizing the circuit, it is important to test all wiring and connections to ensure that they are properly installed and that there are no faults. Use a multimeter to check for continuity, insulation resistance, and voltage. Verify that the grounding system is properly connected and that all bonding connections are secure. Perform a visual inspection of the entire installation to ensure that there are no obvious defects. After the installation is complete, it is important to document all work performed. This includes creating a wiring diagram, labeling all circuits and equipment, and providing training to the elevator maintenance personnel. Proper documentation is essential for troubleshooting and future maintenance. Always follow lockout/tagout procedures when working on electrical equipment. This involves energizing the circuit, locking out the disconnecting means, and tagging it to prevent accidental re-energization. Lockout/tagout procedures are essential for preventing electrical shock and injury. Consider the environmental conditions in which the wiring is being installed. If the wiring is exposed to moisture, chemicals, or extreme temperatures, you may need to use special types of conductors and enclosures that are designed to withstand these conditions. The NEC provides specific requirements for wiring in hazardous locations, such as areas where flammable materials are present. Ensure that all wiring and equipment are properly rated for the environment in which they are being installed. Also consider future expansion when designing the electrical system. It is often more cost-effective to install a larger conduit and pull additional conductors than to have to rerun the wiring later. Plan for future loads and consider the possibility of adding additional equipment to the elevator system. Proper planning can save time and money in the long run. When selecting electrical equipment, choose products that are listed by recognized testing laboratory, such as Underwriters Laboratories or Intertech. Listed equipment has been tested and certified to meet certain safety standards. Using listed equipment helps to ensure that the electrical system is safe and reliable. When working with electricity, always wear appropriate personal protective equipment, such as safety glasses, gloves, and insulated tools. Electricity can be dangerous, and it is important to take precautions to protect yourself from electrical shock and injury. If you are not qualified to work on electrical equipment, hire a licensed electrician to perform the work. Working with electricity can be dangerous, and it is important to have the proper training and experience to do the job safely. Ensure the electrical panel has sufficient space for the new breaker. Overcrowding can lead to overheating and potential hazards. If space is limited, consider upgrading the panel or adding a sub-panel. Check local codes and regulations in addition to the NEC. Local jurisdictions may have additional requirements or amendments to the NEC that must be followed. Contact your local building department to obtain the necessary permits and inspections. Before starting any electrical work, create a detailed plan that outlines the scope of work, materials needed, and procedures to be followed. A well-defined plan can help to ensure that the project is completed safely and efficiently. In conclusion, calculating the wire size and overcurrent protection for an elevator motor involves several steps. Firstly, determine the motor's nameplate amperage. Secondly, apply the 85% factor for intermittent use. Thirdly, select the appropriate conductor size based on the calculated amperage and installation conditions. Fourthly, choose an overcurrent protection device that is sized appropriately for the conductor ampacity. Finally, follow all applicable codes and regulations and take necessary safety precautions to ensure safe and compliant installation. Remember to consult the latest edition of the National Electrical Code and any applicable local codes to ensure that you are following the most up-to-date requirements.